Okay, guys, so let's start the class. And in this class, we are going to discuss the most important Okay, guys, so let's start the class. And in this class, we're going to discuss 85 most important computer science paper 2 questions. Okay, so the paper code, the course code is 0478. Okay, so let's start the class. Okay, question number 1, identify and describe 3 stages of program development life cycle. So we know there are 4 stages of program development life cycle. Okay, so first of all, we have analysis stage, then we have design stage, then we have coding stage, and the last stage is the testing stage. So let's see the details of each stage. So analysis stage, a process of investigation leading to the specification of what a program is required to do. So in this stage, we find the requirements of the program. Okay. Next stage is the design stage. So in this stage, use the program specification from the analysis stage to show how the program should be developed. Okay. So we use the pseudocode, flowchart, and structure diagram in this stage. Then next stage is the coding stage. So we write the code in this stage, the writing of the program or suite of a program. So we do the coding in this stage. Last stage is called the testing stage. In this stage, we test the program with the testing data. Okay, so the completed program is run with the test data to make sure that all of the modules interact correctly and the program as a whole work as intended in all circumstances. Question number 2, tick one box to show which task is part of analysis stage of the program development lifecycle. So option A is testing, option B is coding, option C is decomposition, and option D is design. So as we know that testing, coding, and design, they are the stages of program development lifecycle. So the correct answer is C, decomposition. So decomposition is a part of analysis stage in which we break down the large problem into small manageable tasks. Question number 3, for full description of states in the program development life cycles are shown. Draw one line to link each description to its most appropriate program development lifecycle stage. Not all program development lifecycle stages will be used. So here you can see you have the different stages, for example, analysis stage, coding stage, design stage. And on this side, you have the statements. Okay, so let's read the first statement. Develop an algorithm to solve the problem by using structure diagram, flowchart, and pseudocode. So we know this is the design stage. Okay, so we use those things, structure diagram, flowchart, and pseudocode in design stage. Next statement is detect and fix the errors in the program. So that is the testing stage. Okay, next statement is identify the problem and its requirements. So that's analysis stage. Then you have the write and implement the instruction to solve the problem. So that's the coding stage. Okay. Question number 4, identify 3 different tasks in analysis stage of the program development lifecycle. So what are the 3 different tasks that we need to do in the analysis stage? So first task we need to do is to gather the requirements. Okay. Then you need to analyze the user's need. And the last thing that we need to do in the analysis stage is to define the system specifications. These are the 3 tasks that we need to do in the analysis stage. Question number 5, abstraction, decomposition, and structure diagrams are tools used during the program development life cycle. Identify the stage of the program development life cycle where they are used and describe what they are used for. Okay, so let's first talk about the abstraction. So what is abstraction? It's used in analysis stage. So what is abstraction? Abstraction to identify the key element required, discarding any unnecessary details and information that is not required. So in abstraction, we ignore the irrelevant details and we only focus on the main details that we need to develop our program. Next one is decomposition. So what is decomposition? So it is used in the analysis stage. So what is the use? So to break down a complex problem into smaller parts, repeating this until each part can be solved easily. Okay, so that's the main goal of decomposition, to break down a complex problem into smaller and manageable tasks. Next one is a structure diagram. So what is a structure diagram? It's used in the design state. So what is the purpose? So it's a hierarchical diagram that shows how a computer system can be repeatedly divided into subsystems. So in this one, same thing, we do the decomposition of the problem, but in a hierarchical order. Okay. Let's see the question number 6. State 3 of the component parts of a computer system. So what are the 3 component parts of a computer system? First is input, then you have process, then output, and the last one is the storage. So you can just write any of 3 from those 4. Question number 7, draw a flowchart to convert the length in feet to centimeters. Formula is what? Is length in feet multiplied by 30. So how do we draw the flowchart for this program? So first of all, we know that we need to use this symbol, okay? It's a start symbol. Then we need to ask a user to input the length in feet, okay? Then we need to do what? We need to process it, right? So process what? So we need to calculate the length in centimeters. So what is the formula? Length in feet multiplied by 30. So we'll get the what? We get the length in meter. Then we need to do what? We need to output that LCM value, okay? Length in centimeter value. So we just use the same shape as the input shape to output the LCM. And that's it. Our program is done and we can stop the program. Okay, so we stop the flowchart. Okay, question number 8, draw a flowchart to add 2 numbers entered by the user. So how do you create a flowchart in which you add 2 numbers? So first of all, we use the same shape to start the flowchart, okay? Then we need to ask a user to input 2 numbers. So we use this shape to ask the user to input the number 1 and the number 2. Then we need to add them together. So with this time, we use the process shape. Okay, so this is the shape used to process a total equal to number 1 plus number 2. Then we need to output. Okay, so we use the same shape as this one. Output is what is total. Okay, and then we simply close the flowchart using the stop statement, stop box. Okay. Question number 9, draw a flowchart to read 2 numerical values, determine the largest of the 2 values and output the largest value. So this time we have to find which number or which value is larger. And then for this one, we need to use the if statement. Okay, so for the if, we use the diamond shape to show the if statement in the flowchart. So let's see. So first you start the flowchart with this shape, okay, and then you need to ask a user to input 2 values, value 1 and value 2, okay. Then you need to check if the value 1 is greater than value 2. So for this one, we use the if statement, if value 1 is greater than value 2. So in a flowchart, we use this symbol, diamond symbol, to show the conditional things. Okay, so is value 1 greater than value 2? So it has 2 possible conditions, yes or no. So if value 1 is greater than 2, okay, it's yes, then we need to output a message. We need to output a message that the max value is value 1. Otherwise, if it's no, then we output a message max value is value 2. And then we output the max value, whatever the max value is, we output. Then we need to just stop the program. So that's the very simple diagram using the decision control. Okay, so we're using the if statement here. Okay, question number 10, draw a flowchart to represent an algorithm that reads a number and identifies whether the number is positive or negative. You should use the standard flowchart symbol. So now you need to ask a user to input a number, and then you need to tell whether the number is positive or the negative. The number below 0 are negative, okay, and above 0 are considered as positive numbers. So how we start the flowchart? Simply we just use the start shape, okay. Then we ask a user to input a number. So now we know that we use this shape to ask a user to input a number. So, okay, so we're asking a user to input a number. Then we need to make the decision. Okay, so which statement, which shape we use? We use the diamond shape to make a decision. Is number less than 0? Okay, so if number less than 0, it means it's a negative. Is it above 0? That means it's a positive. So if yes and no, we have 2 possible conditions from this shape. So yes, if yes, then we output the number is what? Negative. And if no, then we output a message showing that the number is positive, and then at the end we can stop the program. Okay, so as you can see, the start and the stop, they are the same shapes. Input and output, we use the same shape, and this is the shape used for the decision making. Okay, next question, draw a flowchart based on the provided code. So you have a code here and you need to draw the flowchart for this code, okay? So let's first read the code. So score equals to 75. If score is greater than 50, then output passed and end if. That's it. All right, so let's see. We start the flowchart with this symbol. Then this line is next, right? Score equal to 75. So what is this? which shape we should use? We should use the process shape. Remember, for assignment, we use the process shape. Okay, so this shape score equal to 5 or 75. Sorry, 7 is something here. Then we have an if statement, right? So which statement, which shape we use? We use the diamond shape to represent the if a score greater than 50. Okay, so if it's true, we do what? We output the message passed, and if false, we do nothing. Okay, so yes, it is yes, then we output a message passed, and then we just need to close the program. That's it. Okay. Question number no, also no. If no, then we just stop the program. We don't have any other statement here. Question number 12. Develop a flowchart based on the provided code. So you have a code here. You need to draw a flowchart for this one. So let's read the code first. Mark equal to 60. If mark is greater than 50, then output message passed. Else output failed and if. Okay. So how do we draw the flowchart? Same thing. We start. Then this statement is assigning the value to a variable. So you know now that we should use the process symbol for this one, right? So we use the rectangle mark equal to 60. Then again, you have if we know we need to use the diamond, it's a decision. Okay, so is mark greater than 50? Then we have two possible values this time. Yes, we output the pass, and if no, we output the fail. So yes is what we can output a message what passed, right? And no, we output a message what failed. And at the end, we need to just stop the program. Question number 13, develop a flowchart based on the provided code. So now you have a code. So you can read the code mark equal to 60. If the mark greater than 80, then output mark A. Else, if mark greater than or equal to 60, then output mark C. Else, output fail and end if. Okay. So as you can see in this code, we have two if statements. Okay. So this is the else if. Okay. So let's try to draw the code flowchart for this program. So first of all, we start the flowchart with the start symbol. Okay, then we need to assign the value to the variable mark. So mark equal to 60, and then we need to use the decision if mark is greater than 80. Okay, so if it's true, we output what? We output the mark A. So yes. In case of yes, we output mark A, but in case of no, we need to have one more if statement here. So we have to make one more decision. So we have the same thing here. So is mark greater than or equal to 60? If it's no, then we output what? Failed. Okay, and if it's true, we output what? We output mark C, this line. Okay, and then at the end we can just stop the program. Okay, I hope now you have understood how to write the flowchart from the code and from the statement. Okay, so now let's see the question number 14. The following four pseudocode statements and their flowchart symbols are given as shown. Draw a line from each to pseudocode. So you have pseudocode and the symbol. You need to connect each pseudocode to the correct shape or symbol. Let's see the first one. First one, if x greater than 12. So it's an if statement, right? So for the if or decision-making statement, we use the diamond symbol. Next, input x. So for the input, we use this symbol. Okay, so we can click this one here. And then next one is x equal to y plus z. So that's the process. We are adding two numbers. So for this one, we use this shape, rectangle shape. Then output equal to x, and we use the input for the input and output. We use this shape. Okay, so we can just connect it here. Okay, question number 15. What is the purpose of the following shape in the flowchart? So you have this shape in the flowchart. Okay, so what is the purpose? Option A, represent a subroutine. Option B, represent a decision. Option C, represent an input and output. And option D, represent a terminator. So we know this is not the terminator. It also doesn't represent the input and output, and also does not represent the decision making. So the correct answer is option A. This shape represents a subroutine. Okay. Question 16. Draw the most appropriate flowchart symbol for each pseudocode statement. Okay, so you have a pseudocode and you have to draw the most appropriate symbol for each pseudocode. First one is if number equal to 20. Okay, so what is this? It's an if statement, right? For the if, we just use this symbol. Okay, so this is the decision making symbol. Next one is number equals to number plus 1. So what is this thing? We are doing a process. We are adding 1 to a value of number. Okay, so that one is what process. We use this shape. Then print number, print and output and input. They we use the same shape for them, or same symbol for them. So we choose this one. Okay. Question 17, describe the purpose of flow lines in the flow chart. So what is meant by the flow lines? Flow lines are the lines that connect two shapes together. Okay, so let's see the definition or the answer for this question. So flow chart flow lines use arrows to show the direction of the flow through the chart, which usually, but not always, top to bottom and left to right. Okay. Question 18. An array called student is used to store the name of 20 students. The array is included from the array is indexed from 0 to 19, so it is like student 0 to 19. The names of the students need to be output using a loop. There are different types of loops that can be used. A precondition loop tests the loop condition at the start of each iteration. Draw a flowchart to show how a precondition loop can be used to output the names of all. Okay, so now we need to draw a flowchart of the what? Precondition loop. What is the precondition loop? It's called the while loop. Why precondition? Because we test the condition first. If the condition is true, then we execute the block of code. Okay, if the condition is false, we ignore the block of code inside the body of the while loop. So let's see how we can draw the flowchart for the while loop. So as always, we start the flowchart with this shape. It's called the start. Then what is next? We ask, we assign the counter to what? 0. Okay, then we say is counter greater than 19. Okay, so if this condition is true, we do what? We ask so no, we output the student and counter. What does mean we counter? The first value of this one. Okay, because the value of counter is 0, so that's why it's not equal, so we can just come here and then we come, next one is counter equal to counter plus 1, and then we just repeat this thing. Okay, so we go, this line goes back to this one, and this code, these two lines of code will run until this condition become false. Once it's become false, and then we can stop the program. So that's the simple flowchart of the precondition loop. Let's see the next example. Next example is the same question, but you need to draw a flowchart using the post condition. So what is the post condition loop? It's the repeat until loop. Okay, so in this one, we test the condition at the bottom. Okay, we simply flip the while loop flowchart. Okay, so you can see start, and then we ask we set the counter to 0. We output student counter, and then here we have counter is equal to counter plus 1, and at the bottom we test the condition. Is counter greater than 19? Okay, if it's no, we go back. If yes, we stop the program. So you can go back and see the precondition and post-condition loop, how it works. Okay, it's very important. Question 20. A program asks the user to enter two numbers. The program then adds the numbers together and output the total. Draw a structure diagram of the program. So now you need to draw a structure diagram of the program. So how do we draw the structure diagram? So when drawing the structure diagram, we know that we have to write the program name at the top, right? So for example, this program is adding two numbers. So we can say this is program name is addition. Then after that, you have to divide this program into three things. First, inputs, what are the processes, and the last one is what are the outputs. If you divide any structure diagram into three parts, it's very easy for you to draw the other, like for what are the inputs, what are the processes, and what are the outputs. So you can easily draw. Okay, so what is the input? Number 1, and then you have a number 2. What is the process? Process is a total equal to number 1 plus number 2, because this is adding two numbers, two values together, right? So we can say number 1 plus number 2. And then what is the output? Output is the total. All right, so you can have a look at this flowchart, how we draw the flowchart. Question number 21. A satellite navigation system needs to ask the user to input their destination. It then finds the route to the destination and output the instruction to the user. Draw a structure diagram of the for the system. So we know that first of all we need to write the name of that program on the top. So what is the name of the program? Is satellite navigation system. So we can just say sat nav or satellite navigation system. Okay. Then we divide this program into three things. First is input, then is process, and the last one is the output. Okay, so now we need to find from here what are the inputs for this program. So as we can read from here, the inputs is what? Input is the destination. User will input the destination. So what is the process? Okay, so we can also get information of the process. So the process is find the what? Find the route. And what is the output? Output is to show the direction. Okay, so this is the simple structure diagram of this program. Question 22. A login system is required. The system asks the user to enter their username and password. It checks if these are valid. If they are correct, the system output that they are correct. If they are incorrect, the system outputs that they are incorrect and prompt the user to re-enter their username and the password. Draw a structure diagram for this login system. Okay, so this is a kind of a complicated question. So now how can we approach this question? So same thing. First of all, you need to write the name of the program at the top. So what is the name of the program? It's a login system. So we can just say login system. Okay. Then we divide this to three things. First, what are the inputs? What is the process? And what are the outputs? Now let's find what are the inputs. So this program accepts two things, usernames and passwords. So these are the two inputs. Okay. So we can write it down. So first input is the username and second input is the password. So what is the process? Okay. So process, there are two processes for this program. First one is finding the username in the database and then matching the username with the name inside the database and also matching the password. Okay. So two processes. First one is what? Find the username and the password. And step number two, second process is compare username and the password with the data. Is the register is with the database. Then what is the output? Output is the two messages, right? If it's correct, okay, the password and username are matched, it will just show a message correct. And if it is incorrect, okay, doesn't match, then it will show a message incorrect and ask the user to re-enter the re-enter the username and password. I hope now you have understood how to create the structure diagrams. Okay, tick one box to show. Tick one box in each row to identify the statement about the structure diagram is true or false. Okay, here we have some statements. Statement number one, a structure diagram is a piece of code that is available through the structure of the program. So that is false, right? Okay, because it's a what? It's not a code, it's a diagram. A structure diagram shows the hierarchy of the system. That's true. A structure diagram is another name of an array. False. A structure diagram shows the relationship between the different components of the system. That is true. Question 24. Now let's talk about the test data. So let's first review the test data. We have four types of test data. First one is the normal test data. So that data that the program should accept. Then you have abnormal data, that the data that the program should not accept. Then extreme data, data that at the edge of what is allowed. And last type of data is called the boundary data, data that is on the edge of being accepted and being rejected. Okay, these are the four test data that we need to use to test the program. So now let's see some question about the test data. Question number one, a program allows the user to enter 5 numbers between 1 to 5. Find normal, abnormal, boundary, and extreme input values for the program. So now we know that a program that allow a user to only input the values from 1 to 5. So 1 to 5 is what is our normal data. Okay. Next, let's see what is the abnormal data. Abnormal data, anything out of this range, out of 1 and 5. So let's say 0 or 6 or ABC or anything that is outside of this range is the abnormal data. Next one, what is the extreme data? Extreme data is the start value and the end value is the extreme data. Last type of data is called the boundary data. So what is the boundary data? Boundary data is start value minus 1 and the end value or the last value plus 1. Okay, so you can take a screenshot of this diagram. I think it will help you to remember the extreme, boundary, and normal data. I think usually the students are confused between extreme data and boundary data. So if you have this screenshot, you can easily recall this information. Question 26. A program allowed the user to enter their age as whole number between 10 and 100 years, inclusive. Give example of the following types of test data for this program: normal data, abnormal data, extreme data, and boundary data. Okay. So I hope you understood the problem. Now let's find what is the normal data. So normal data for this program will be any number between 10 and 100 inclusive, for example, 10, 20, 50, and 100. Okay. Next, abnormal data, any data that is not a number between 10 to 100, for example, 9, -1, 11, 200, age, 12.2. Okay. What is extreme beta? The largest number accepted is 100 and the smallest number accepted is 10. This is our what? Extreme beta. What is the boundary data? The boundary data for this program is 100 and 101 and 9 and 10. So either side of the largest bound 100 and 101 and either side of the smallest bound 9 and 10 is our boundary data. Okay, question 27. A program asks the user to input a number between 1 and 10 inclusive. Identify the test data for this program. I think now you need no normal data for this program is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Abnormal data, anything less than 1 or greater than 10, or any character, string, example A, 2.5, 8, -1, 5, etc. Extreme beta, 1 is 10, 1 and 10. Boundary data is 0 and 1 and 10 and 11. Okay. Let's move to the question number 28. A user needs to enter a password that is at least 8 characters long. Provide an example of valid test data for this program. So now this is a kind of a complicated problem. So how will you approach this one? So what is the normal data for this program? Any set of 8 or more characters, but they must be text. Okay. Have speech mark, like enclosed in the speech mark. For example, this one and this one is our valid data. Next one is abnormal data, any set of characters with 7 or less characters. For example, this and this is abnormal data. Extreme beta, any with 8 characters only. For example, this and this is our extreme beta. Last one is the boundary data, either side of 8 characters bound, 7 characters or 8 characters. For example, this one, this one, this one. These are all our boundary data for this program. Question number 29. Explain the purpose of using test data in software development and testing. So what is the purpose of using the test data? So the purpose is the test data is a set of values used to determine whether a solution is working as it should. Okay, so test the software. Question 30. Boundary data is one type of test data. Identify and describe 3 other types of test data. So we know now normal data, abnormal data, extreme data, and the boundary data. There are 4 types. Question 31. Give the set of boundary data needed to check that a whole number is less than 50. Less than 50. Okay. So 49 inside the boundary and 50 outside the boundary. Okay. So this is our boundary data. Okay. Next question. A programmer writes a program to weight basket of fruits in grams. Keeping a total of the weight and counting the number of basket. The total weight is stored in a variable called total. And a number of basket is stored in a variable called basket count. Explain how the program can use these variables to calculate the total weight of the basket and the total number of baskets. Include example of programming statements that would be used for totaling the weight and counting the baskets. So you can see what is totaling. Totaling is adding the weight of each basket to the total weight as each weight is entered. What is the formula? So here is the example. Total is equal to total plus weight. Next one is the counting. Counting, adding 1 of the number. So adding 1 to the number of basket as each weight is entered. So what is the formula? So it's basket count is equal to basket count plus 1. That's how we can find the totaling and counting. Okay, question 33. Explain the difference between programming concept of counting and totaling. Include an example of programming statement for each concept in your explanation. So what is totaling? Totaling is used to sum a list of numbers, and here is the example. Total is equal to total plus number. Next one is counting. Counting is used to count how many numbers or items there are in a list. So example include counter is equal to counter plus 1. Question 34. Provide the pseudocode that perform the desired task. So first task is the count control loop, then the precondition loop, and the post-condition loop. You need to provide the pseudocode for this one. So here is the pseudocode. For is a keyword, start is a variable, okay, to the end value, and then you have the statements, and then the next, and the same start value is here. Start variable is here. Then the precondition loop. So precondition loop start with a while, then you have a condition, then you have a keyword do, then you have a statement or the block of the code that will run when the condition is true, and then you will end the while loop with the keyword and while. Then you have the post condition. The post condition starts with the keyword repeat. Then you have the statements, and then at the end you have the keyword until, and after the until keyword you have a condition. Okay. Let's move to the next one. Provide the pseudocode that perform the described task. So first one is totaling, second one is counting, and third one is average. So how we perform the totaling? So first of all, we need to create a variable total and assign it the value 0. Remember, it is important, okay? If you do not assign the value 0, it will give you the wrong answer. Then total is equal to total plus number. Counting, same thing. Count is equal to 0 and count is equal to count plus 1. Then average. How to calculate the average? At first, you create a variable average and assign the value 0, and average is equal to total divided by count. So before getting the average, you have to have the total and the count. Otherwise, you won't be able to get the average. Question 36, provide pseudocode that perform the described task. So first one is the structure of if-else and the case of. These are the two important statements that you need to, okay? So here is the structure of if-else, how you write in pseudocode. So first you have if, then you have a condition, then you have a keyword then. Then you have the statements. So if the condition is true, then these statements will run. Else, if the condition is false, then you will run those statements, and it closes with the and if keyword. Then the case of. So case of statement start with the keyword case of, and then you have a variable name. And then you have the value 1, value 2. So if the value 1, if the variable value is matching with the value 1, then you execute this line. If the variable value matches with the value 2, will execute this statement. And if it doesn't match with any values mentioned here, it will execute the otherwise statement. Otherwise is same as else. Okay. And we close the case statement with the end case keyword. Okay. Question 37, provide the pseudocode that perform the described task. So the first task is how you define a procedure, and second one is how you define a function. So you need to know the difference between the procedure and function. Procedure does not return a value, while a function returns a value. Okay. So how do we create a procedure? So first you use the keyword procedure, then the name of the procedure, and then you have to add the parameters. So it should be multiple parameters. Then the block of code, you need to add the statements that you want to execute inside that procedure, and then it closes with the end procedure. So to call, we just simply need to use the name of the procedure with the specify the parameters, and this is how we call the procedure. Then let's see the function. So how we create a function. So first we use the keyword function, then you have a function name, and then in the bracket you specify the parameters, and then you also specify the return data type. So return is a keyword, data type is the type that you want the function to return. For example, int, string, char, or whatever data type you want, you can just specify it here. Then you have the statements, okay, or the code that you want to run, and at the last you have the return, and you should specify which value you want to return here after the return keyword, and function is closed with the end function keyword. Okay, let's question 38. Identify which validation rule this algorithm uses. So let's see the algorithm. So input num, and if the num is greater than 0 and num is less than 100, then output the valid, else output invalid. So this is what check is the range check. Okay, next one. Okay, so this time I want you to comment the correct answer. So here you can see identify which validation rule this program uses. So first, repeat input value if value not equal to null and value is not equal to empty. So I'll pause for 5 seconds, and you can quickly write your answer and see. Let's see if your answer is correct or not. The correct answer is presence check. Okay. Question 40. Explain what is meant by validation and verification. Give an example for each one. So what is the data validation and data verification? So validation is checking if the data is reasonable and meets the certain criteria. Okay, an example of validation are what? Range check, length check, type check, check criteria, etc. Then you have the data verification. So it's checking if the data entered into the computer matches the original source of the data. An example of verification are double entry and visual check. Okay. Question 41. Take one box in each row to identify if the statement is about validation or verification. Statement number 1, a check where data is re-entered to make sure no errors have been introduced during the data entry. So that is what? That is the verification. And what is the name of this one? It's called the double entry. An automatic check to make sure the data entered has correct number of characters. So that's the validation. And so it's called, which validation is a range check, okay, or length check. Next one, a check to make sure the data entered is sensible. So what is this one? It is also validation. Okay, so we use validation to make sure the data that we entered is readable, for example, in the correct format or in the correct data type or in the correct length. Question 42, a program checks that the data entered is between 1 and 100 inclusive. Identify one piece of normal, extreme, and erroneous data for this program and give a reason for each. Okay. Okay, so I will tell you the normal and extreme data for this program. Can you tell me what is meant by this word, erroneous test data? What is this one? Okay. So this answer, normal test data is what is the data, for example, 50, allow any number between 1 and 100 inclusive, and the reason data that is within the range and should be accepted. Second one is extreme data, test data, that is test data, like for example, 101, reason the data at maximum and minimum end of the range and should be accepted. Last one is this one, erroneous data. So that is abnormal data. Okay, remember this one. It's the new name. So erroneous test data is what? The test data, example 300, allow anything that isn't between 1 and 100 inclusive, including other data types, for example, characters or string or anything. Okay. Reason the data outside the range that should be rejected. So this is the three types of data: normal, extreme, and erroneous or abnormal. Question 43. A program can perform validation and verification checks when data is entered. Identify two different types of validation checks and explain the purpose of each one. So now what are the two types of validation checks? So we know we have one, presence check, ensure the data has been entered into the field. Next one is the length check to ensure data is the correct number of characters or the digits. Then you have the range check, ensure the data is within a specified upper and the lower limit. Then you have a type check, ensures that data is of a certain data type like integer or text. And then we have the format check, ensure the data follow a specific pattern or structure. Okay, so these are the 5 examples of the validation checks. Give the name of one verification check that can be performed on the data when it is entered into a program. What is this question? Give the name of one verification check that can be performed on data when it's entered into a system. Right? When you are entering the data into a system, so we can use the double entry, okay, to make sure that it is correctly entered. And then also one is the visual check, okay. We can visually check the data with the source data. Question 45. Describe the difference between validation and verification in the context of data entry in computer programs. Okay, so difference. Again, I think it's this question we have already discussed, but let's see the what is answer here. So validation checks if the data is reasonable or in the correct format. Number 2, verification checks if the data is accurate or matches the original source. Okay, so that's the difference between the validation and verification. Question 46. Identify a suitable validation check for the email address test data. This is the email address id27@cambridgeuni.com. And describe how this validation checks would be implemented. Ensure that the validation check you choose is appropriate for verifying the format of an email address. So what we can use the validation check name. We can use the length check. Why? Because count the number of character in the data to make sure that it isn't too long. For example, max length for the email address could be 320 characters, so it doesn't go like not more than 320 characters. Next one, identify a suitable validation check that could be used for each piece of normal test data and describe how it would be used. Each validation check must be different. Test data for entering a year 2021. So we have to enter the year 2021 and what should be the check we should use. So we can use the range check, okay, or check that the number entered fits within a given parameter or given range. The next one is the test data for entering a name, Erickson Bower. So what should be the correct data? Correct the validation check for this one. So we can use the type check to make sure that they don't enter any numbers. The checks the type of the data entered, in this case, to make sure that no numbers are present. Okay. Question 49. The programmer has also decided to validate the email address and the password. Describe the validation checks that could be used. So for the email, we can use the presence check to ensure the email field is not empty, and we can use the format check to ensure the email is in the correct format. Then for the password, we can use the presence check to ensure the password field is not empty, and we can also use the length check to ensure the password is at least 8 characters long. Okay. Question 50. 4 description of validation checks are shown. Draw one line to link each description to the most appropriate check. Not all checks will be used. Okay. So here we have check digit, format check, length check, presence check, and type check. And here we have statement. Statement number 1. To check that the data entered is an integer. So we use the type check, we use the type check for this one. Okay, check the type of data. If the data is integer, float, or char. To check that some data has been entered, so we need to use the presence check for this one. Okay. To check that the data entered has an appropriate number of characters. So what we need to use? We need to use the length check for this one. And the last option is to check that an identical number contains no errors. So what we should use? No errors. We should use the format check. Oh, sorry, it's the identification number. Okay, identification or ID number. Okay, question number 51. Data entered by a customer includes the age of the driver. Identify 2 different validation checks that could be used for the age of the driver. Justify your choice for each validation check. Okay, so we can use the check is presence check. Reason, need to enter age to calculate the price. Okay, and the second one we can use the type check. Verifies that the age entered is numerical value and preventing non-numerical inputs like letters or symbols that would not represent a valid age. Then check, we can use the range check. Range check is used for what? So ensuring the age entered falls within a realistic range, such as 17 to 100, to confirm that the driver is a legal driver is of legal driving age and not excessively old. Okay. So that's question number 51. Let's see the question number 52. Now let's talk about the trace tables, okay? I've traced the following algorithm using the input values of 1 and 3. Provide the step-by-step output for each stage of the algorithm. Okay, so this question is very easy, okay? And then later we'll have some difficult questions, so stay tuned. Okay, so when creating the flowchart, we first need to have all the variables. So we know we have 2 variables, number 1 and number 2, and there's no other variable. And then you have to have a output column, right? So what is the value of number 1? So input number 1, the value of number 1 is mentioned here is what? 1. What is the input value number 2 is mentioned here in the question is number 3. Okay, and output is 0. Now we come here. If number 1 is greater than number 2, if this condition is true, we output what? We output number 1. Else we output number 2. So value, which one is output? We output the number what? Number 2, which is what? 3, because it's greater. So that's a very simple trace table. Okay, that's how you use the trace, how you trace a code. Okay, using the trace table. Okay, guys, I'm back from a short break. Let's continue, okay? Question 53. Trace the following algorithm using the input values of 4, 3, 2, 1, and 0. Okay, so let's see the algorithm. It's the algorithm. So first, let me create the trace table. Okay, so we know that we have to have the variables, all the variable names, count, input value, second variable, then we have a total variable. Okay, and what else we have? We have no other variable, so we can just say output. Okay, so now let's start. So what is the value of count? First, we add the value of count is 0. Input value is what? 1. The value of total is what? 0. Then we are in the while loop. We check the condition if the input value is greater than 0. So input value is what? Input value is 1 is greater than 0. It's true. We go inside the loop. And what is the first input value? And from where we get is already given in the question here. Okay. So what is the first value is 4. So we write 4 here under the input value. Okay. What is next? Total equal to total plus input value. So what is the total? Total is 0. 0 plus input value is what? 0 plus 4 is what? 4. And then count equal to count plus 1. What is the value of count? Count is 0. 0 plus 1 is what? 1. Okay. So remember, we're still in the loop. We go back. We check again. Input value is greater than 0. This condition is true because it's 4, right? If it's true, we go inside again. We input value. So we need to input a value. What is the next input value? Is 3 given here. So we have right here. Input value is 3. Okay. Next, then total equal to total plus input value. So what is the total? Total is 4. 4 plus 3 is what? 4 plus 3 is 7. Then count equal to count plus 1. So what is count? Count is 1. 1 plus 1 is 2. Okay, and then no output so far. We go back again. We check again. The input value is greater than 0. So what is the input value? Input value is 3. 3 is greater than 0. The condition is true. We go inside the for loop. Okay, input value. What is the input value this time? We are here 2. So input value is what? 2. Then total equal to total plus input value. So what is total? Total is 7. 7 plus 2 is what? 9. Okay. And then count equal to count plus 1. So count is 2. 2 plus 1 is what? 3. And there is no output so far. We go back again. We check the condition. So 2 is greater than 0 is true. So the input value is 2. 2 is greater than 0. This condition is true. We go inside and we ask a user to input a value. Okay. So what is input value? Its input value is 1. So we say input value is 1. Then total is equal to total plus input value. So what is total? Total is 9 and input value is what? 1. 9 plus 1 is 10. And then count equal to count plus 1. So 3 plus 1 is the 4, right? And there is no output. So now we go back again. So this time we ask a user to input, we check the condition. So input value is what? Input value is 1 and 1 is greater than 0. This condition is true. We go inside the loop. We ask a user to input a value. So what is the input? Next input? Next input is what? 0. Okay, so we input 0. And then total equal to total plus input value. So total is what? 10. 10 plus 0 is what? 10. And count equal to count plus 1. So count is 4. 4 plus 1 is what? 5. Okay. And there is no output. We go back again. Okay. We check this time. So input value is greater than 0. So 0 is not greater than 0, right? So it means this condition is become false now. So we ignore those lines of code. We come outside of the loop here. So now we need to output the message. This one output total is total. So what is total? Total is 10. So we show this message in the output window here, output column here. We can just show total is 10 because the value of total is 10. Then next output is what? There were count numbers. So what is the value of count? Count value is 5. So we can simply say there were 5 numbers. That's how we trace the table step by step. Okay. Okay. Let's see another example. So create a trace table for the following code. Input values are 80, 100, 30, 20, and 50, and -1. Okay. So then we have our code, pseudocode. Okay. And now let's create a trace table. So how we create a trace table? We add all the variables. So we have total 1 variable, then you have a count variable, then you have a mark variable. Let's see if we have any other variable. Oh yeah, we have average variable. Okay. And there is no, and we can just simply write the output. Okay. The output is the one column where we show our outputs. Okay. So now let's start the tracing the code. So what is the first line? Total equal to 0. So we add 0 here. Count is equal to 0. We add 0 here. Mark is equal to 0. We add 0 here, and average and output are empty. Nothing. Okay. Then we have a while loop. Line number 4. A while mark not equal to -1. Okay. So the value of mark is not equal to -1. Is this condition true? Yes, it's true because 0 is not equal to -1. Then we go inside the while loop. So what is the first statement? Input mark. So where do we get the mark? So here is the mark value. The first value of the mark is what? 80. So we write 80 here under this one. And then if mark is greater than 50, if the mark value is greater than 50, is greater than 50, yes, it's true. So we go inside the if statement now. Count equal to count plus 1. So what is count? Count is 0. 0 plus 1 is what? 1. Total equal to total plus mark. What is total? Total is 0. 0 plus mark is what? 80. Okay, and then is no output. Then we are still in the loop. We came to the line number 10. We go back again here. We check if the mark not equal to -1. Yes, mark value is 80 is not equal to -1. We go again. We ask the user to input the mark. So what is the next input? Input is what? 100. So we write 100 here. And then we check if mark is greater than 50. So that's true. 100 is greater than 50. We go inside the if block. So count equal to count plus 1. So count is what? 1. 1 plus 1 is what? 2. And then total equal to total plus mark. So total is what? 80. And 80 plus mark is what? 180. Okay. And then no average, no output. Still, we come here. We go back again because still the loop condition was true, right? So mark not equal to -1. That condition is true. Mark is 100 and it's not equal to -1. So we continue. Input mark. So what is the next input value? Is 30. Okay. So we write 30 here. Then we check here if mark is greater than 50. No, mark is not greater than 50. Okay, so we skip those 2 lines of code. Okay, and we go back again. Again, we check if mark not equal to -1. So this condition is again true because mark is 30. Okay, it's not equal to -1. We ask the user to input the mark. So what is the next input? Next input is what? 20. Okay, so we write 20 here. And again, mark 20. 20 is less than 20 is mark is greater than what? 50. It's not greater than 50. So we ignore those 2 lines. Okay. And then we go back again here. This time the input is what? Input is what? 50. So we add 50 here. And again, 50 is mark is not greater than 50. So we again ignore those 2 lines. We go back again. And this time its condition is true because it's 50 and we ask the user to input mark. So this time user input what? -1. Okay. Again, -1 is not, mark is not greater than 50. So we ignore those 2 lines and we go back again and check this one. Mark not equal to -1. So this condition is false now. Okay. So because mark value is what? -1. So we ignore all this code and we come here on line number 11. Okay. So line number 11 says average equal to total divided by count. So what is the value of total? Total is 180. And what is the count? Count is what? 2. So 180 divided by 2 is what? Is 90. And then we output what? We output count, comma, average. So what is the value of count? Count is 2 and average is what? 90. So our answer will be 2 and 90. Okay, that's how you create a trace table or trace a code using the trace table. Okay, so now we have another problem. This problem is similar. Okay, so the flowchart below inputs the height of children who want to ride a roller coaster. Children under 1.2 meters are rejected. The ride starts when the 8 children have been accepted and complete the trace table for the following input data. So these are the input data and this is a flowchart and you need to follow this flowchart to create the trace table. Same thing. You have to follow the same method that we have followed in the last few questions and let's create a trace table. So first of all, we need to find the variable. So first variable is what? Riders. Okay, we have riders here. Then you have reject. We add reject variable here. Then we have height. This is another variable. We add the height here. Okay, and let's see what else we have. We have, I think, any other variable, reject, height. Okay, we don't have any other variable. So now we just add the output. Okay, so now let's start tracing the code. So first statement is what? Rider equal to 0. So rider is the value of rider is 0. Reject is also 0. And ask the user to input the height. So now we're asking the user to input height. So what is the first value of input? Is 1.4. Okay. Then we go what? We need to check if is height greater than less than 1.2, is less than 1.2, if yes or no. If is no, then we add rider plus 1. So is rider plus 1 is what? 0 plus 1 is what? 1. Then we go down, rider is equal to again we check is rider equal to 8. So rider is not equal to 8. So this condition is no. We go back again here. Ask the user to input the next value. Next value is what? 1.3. Okay. 1.3. Then we check again if if is the height height is less than 1.2, so it's no, right? So we come here. Rider is equal to rider plus 1. So what is rider? Rider is 1. 1 plus 1 is what? 2. And then again, we check is rider equal to 8. So rider is not equal to 8. We go back again here. Again, we ask the user to input the what height. So what is the height? This time height is 1.1. Okay. Again, we check height. Is height less than 1.2? So this time it's true. So now we do what? We come here, this time, this way. Reject equal to reject plus 1. So we add 1 to the value of reject. And then we go back again. Okay. We ask the user to input the next value. Next value is what? 1.3. Okay. 1.3. Then we again check is height is less than 1.2 is false. We come here, rider equal to rider plus 1. So rider will become what? Rider will become 3. And then we come here, we check again, riders are equal to 8. It's not 8, it's 3, right? We go back again. Ask the user to input the height. Next height is what? 1.0. 1.0 is what is reject here. And we add 1 to the value of reject. So reject will become 2 and nothing here and nothing here. Okay, again, we come back here, ask the user to input the height. Next height is 1.5. Okay, so we add 1.5 here. Then we check is the height is less than 1.2. This is no. In case of no, we come here, rider equal to rider plus 1. So rider is what? 3. 3 plus 1 is what? 4. And then we again check is rider equal to 8. Is no. And then if no, we go back here again. We ask the user to input the next value. Okay, next value is what? 1.2. 1.2 is here, and then we again check is height less than 1.2. So it's not less than 1.2. We can just add 1 to the rider, and then again we check is it 8. It's not 8. We can again go back. Okay, this time the input is what? 1.3. Again, when 1.3, we add 1 to the riders. Okay, and then we can again go back to the ask the next input. Next input is what? 1.4. 1.4 is not less than 1.2, and we add 1 to the riders. Okay, the rider becomes 7. Then again, the next value is what? 1.4, 1.3. 1.3 is the next value. Okay, here, and then 1.3 is also not less than 1.2. So we add 1 here. So now the value become 8. Okay, so we come here now. This time we check the rider equal to 8. So yes, rider is equal to 8. If rider is equal to 8, we need to do what? We need to go this way. Okay, and say output ready to go. So we need to output a message ready to go. Okay. Ready to go, and then we just end the program. So that's how you trace an algorithm if it's given in the form of flowchart. Okay, let's move to the next question. Okay, so this is the question. I think this is the same question. Okay, this is the same question. So we have already solved this one. So let's skip this one. Let me quickly skip this one. Okay. Okay. Let me quick go. Okay. Question number 57. Example 1. Describe the purpose of algorithm. So how you can describe the purpose of an algorithm, because there is one question in the exam. They will give you a code and ask you to describe the purpose of an algorithm. Okay, so I'll let you know some tips and tricks to find the purpose of an algorithm. Okay, first of all, there are two ways. Okay, one way is using the trace table. You can create a trace table, and then you can, by using the trace table and run the program in the trace table to find the purpose of the program. Okay, so how do we create the trace table? First of all, you need to know that you need to find all the variables in the code and add them as an individual column. So first we have variable value 1 is a variable, value 2 is a variable, value 3 is a variable. So you need to find if there is any other variable. All the variables you need to list them here. Variable 1, 2, 3, and last you need to add a column as output. Okay, now next step is you need to run them with your own values or own numbers if you're not given. Because in the last question we were given some input values, but here we don't have any input values, so we can just design our own set of values and we can run those values. Okay, so let's see. So use the test values if not provided, and let's say we are just using the test value 1, 2, and 3. These are our test values we're going to run. So if value 1 is greater than value 2 and value 1 is greater than value 3, if this condition is true, then we output what? Value 1. Else if value 2 is greater than value 1 and value 2 is greater than value 3, we output value 2, and else we output the value 3. We just need to compare them. Okay. So in this case, what will be the output? The output will be 3 because 3 is the largest number in those three values, right? So we're not done yet. Okay, so you need to test it with some other numbers as well to make sure that your answer is correct. So now let's find some other values to, sorry, we also have what thing? We have to output the, okay, after the it's one, you need to print the output, and also you need to do what? Value 1 plus value 2 plus, value 1 plus value 2 plus value 1. So value 1 plus value 2 is what? 3. 3 plus what? Value 1. Value 1 is what? Is 1. Okay, so here's the mistake, I think. Yeah, so it should be value 1. 1 plus 2 is what? 3. 3 plus 1 is 4. It should be 4 here, okay? That's a mistake. So now we're done. Now let's run them. So repeat the process with different set of data until you find the pattern, okay? So now let's add some new patterns, so new value numbers. So let's say 10, 20, and 30, 50, sorry, okay? The same thing, it gives you the output 20, and this is the number when you add those values together. And now you know what is the purpose of this program. So what are the 3 things that this program is doing? First of all, it's asking you to input 3 values, right? Then it's comparing those 3 values together and finding the maximum value. And then it is what? It is adding those values together. So it will be value 3, okay? So adding those 3 values together and showing you the sum. What is the purpose? The algorithm asks the user to input 3 numbers. It compared those 3 numbers and output the largest number and the sum of the 3 input numbers. So that's how you find the purpose of an algorithm. Okay, using the trace table. What are the key takeaways from this questions? First of all, you need to create a trace table, okay? And then you need to find some set of values that you want, that you can use to test the program, and make sure you test with the 2 different set of values. Okay, not rely on only one set of values. Okay, and that's how you will find the purpose of an algorithm. So make sure you write the details. So for example, let's ask the 3 input as number as input. Okay, then it compared those 3 numbers and output the largest number, and then also the output the sum of those 3 numbers. Okay, question number 58. Example 1. Describe the purpose of the algorithm. Input values are this one. I think now it's easy for you. So we have variables like quantity, total, value, small, and yeah, that's it. And we have output column. So what is the value of quantity? Is 0, and our total is 0. Value is 0. Small is 999, and output is nothing. Okay, so while quantity is less than 5, we do what? We ask the user to input a value. So what is the first input value? Is 1. Okay, then if the input value, if the value is greater than 10 and value is less than or equal to 100, and what we do, we need to have a quantity equal to quantity plus 1. So quantity is what? Value is what? 100, and quantity is equal to quantity plus 1. And then total equal to total plus value. What is total? Total is 0. 0 plus value is 100. And then if the value is less than small, then small equal to value. So what is the small? Small will become 100. Okay. And then we are still in the loop, so we go back. Okay, we can check the quantity is less than 5. So no, quantity is not less than 5. Quantity is 1. Yes, quantity is less than 5 is 1. Yeah, okay, this condition is true. Then we ask the user to input a value. So what is the next input value? Is what? 100. Also 50. 50. Okay, 50. Then we come again, and then we check if the value is greater than or equal to 10 and the value is less than or equal to 100, and then we say what? Quantity is equal to quantity plus 1. Okay, the quantity will become 2. Total is equal to total plus value. What is total? Total is what? 100. 100 plus value is what? Become 150. Then we check again if the value is less than small. So what is the value? Value is 50, and 50 is less than small. Yes, it is small. And then we replace the value stored in the small with this number. So it become small will become 50. Okay. We go back again. Again, we check again the next input, the next value, which is 10. And then again, we add 1 to the quantity, it will become 3. Okay. And then total will become what? 160. 150 plus 10 will be 160. And then again, we check if it's small. Yes, it is small. We replace small value with the small variable with the value variable. Okay. Then again, we input the next value, 33. 33 is what? And then we again add 1 to the quantity and add 33 to the 160. Okay, it's become 193. And then we check this one. So this is 10 is less than 33. So this time we will not replace any value in the small variable. We ignore this code. Okay, we ignore this code. Okay, next we again go back. We check, yes, quantity is less than what? 5 is true. Then we go back again, we add the next value, which is what? 42. 42, sorry. Oh, yes, 3. Okay, it's 3. 193, and then we add 3 to 193 is become 196. Oh, sorry, we need to check this one condition. So if the value is greater than 10, so it's not greater than 10, so we ignore this line of code all and we go back again here. And then again, we check if the value is what, less than 5. Yes, it's less than 5. Okay, quantity, the quantity is less than, it's just 4, right? It's less than 5. Then we ask the user to input the value. So last input value is what, 42. So we input 42 here. And then we again check, we go inside, we add quantity equal to quantity plus 1. So quantity will become 5. Total is equal to total plus value. So total is 193 plus 42 will become 235. And we check again if the value is less than small. No, it's not less than small. So we ignore those two lines and we come back and we go back here again. Okay, so this time we check quantity is less than 5. Quantity value is 5. It's not less than 5. So we ignore all this code. Okay, and we just go outside of the code here. So output what? Output small is equal to small. So this time we need to output a massive small value with the massive small. So small equal to what? Small. What is the value of small? It's 10. Okay, so 0 is here, it's down. And then output total equal to total divided by quantity. What is the total? Total is 235 and divided by quantity. Quantity is 5, and you will get the 47 if you divide those two numbers. So that's how you'll find that the purpose. So what is the purpose of this program? So the purpose of this program is to, number one, the smallest number input between 10 and 100, and the average of the number entered that are between 10 to 100. Okay. Next question, question number 59. Identify the correct errors. Identify and correct the errors in the following program program description. This program is supposed to take 5 numbers as input and output the total of all the numbers, and inputs are 1, 2, 3, 4, 5. So now you need to find the error in this code. So there's also one question where you need to read the algorithm or pseudocode and find the errors. Okay, so let's see how we can find the error. So let's use the trace table method. So we have two methods. One is a trace table method. Let's use the trace table method. So first of all, what's the value of total is 1, quantity is 1, and quantity is less than 5. Yes, it's true. We go inside, we ask a user to input the numbers. First input is 1. Total equal to total is equal to number. So what is the total? Total is 1. 1 equal to number is become what? 1. Then quantity equal to quantity plus 1. So what is the quantity? Quantity is 1. 1 plus 1 is become 2. Okay, and there is no output. Then when we sit in the loop, we go back, we check, is the quantity less than 5? Quantity is 2. Yes, it's less than 5. Ask the user to input number. So next input is what? 2. Then we total equal to number. So total will become 2. Okay. And the quantity equal to quantity plus 1. So quantity will become 3, and there is no output. We are still in the loop. We go back. We check the quantity. Quantity is what? 3. 3 is less than 5. This condition is true. We ask the user to input a number. Next input is what? 3. 3, and then we total equal to number. So total is what? Total will become 3, and then quantity is what? Quantity plus 1. So quantity is become 4. Okay. Then we are still in the loop. We go back again and we check. So this is condition true. We ask a user to input. So input is what? 4, and then total will what? Total is 4, become 4, and quantity is equal to quantity plus 1. So quantity will become the 5. Okay. Next, we go back again and we check. Still number is 4 and it's less than 5. It's true. We go inside. We ask a user to input a number. This time user will input number 5. Okay. And then 5. Sorry. Quantity is less than 5. That's true. Quantity is less than 5. Quantity is less than 5. Value of quantity. Oh, yeah. Quantity is value is 5. Just so I'm looking at the number value. So value of quantity is what? 5. So it's not less than 5. So we ignore this line of code and we come outside of the loop. And here we output the total. So what is the total? Total is 4, which is what? Incorrect. So what is the first error? The first error, you can see it here. So whenever you want to find the total of any number, you need to first define your variable total and assign the value to the total variable to what? 0. Next error is here, quantity equal to 0, 1, it should be equal to 0. Then again, here is our condition. There's some problem with the condition. We'll see this one. And the next problem is here, total is equal to number. It should be total equal to total plus number. And let's see what other mistake we have. Yeah, we could have no other mistakes. So let's continue with this program and let's debug the program. Okay. So first of all, the total starts at 0, not at 1. So this is the first problem. Okay. In line number 1. Next is line number 3, that we need to change the condition to either quantity less than 6 or quantity is less than or equal to 5. So here is a problem with the condition. Okay. Next, third problem with this one is total equal to number. So it should be the variable total is overwritten each time. Correct version is what? Total equal to total plus number. So that's how you can correct code with the errors. Okay, so let's see this is the code with the error. So total equal to what? 1. We have to make it what? We have to make it 0. Then while quantity less than 5, so we have to make it less than or equal to 5 or less than 6. Okay. Then input is what? Number is okay. Total equal to total plus number. So it should be total is equal to total plus number. And that's it. So these are the 3 mistakes. And this is the code with the errors. And this is the code after we fix the code. That's how the code looks like after the finding and correcting the errors. I hope you got the idea how to find the errors in the code. Let's see the question number 62. The following algorithm is designed to take 3 numbers as input and output both the largest value and the average value. Identify the 3 errors in the code. Okay, so now this time we're going to use a different approach to find the errors in the code. So in this one, first of all, you need to see what does the program need to do. Okay, so first of all, we know that the first task it needs to do is to take 3 numbers. Okay, so we need to see, is it taking 3 numbers? Then it need to find the largest number. Okay, how we find the largest number? So first of all, we create a variable largest and give it a very small value, and then we just compare the value and store it in that one. Okay. Third thing it need to do is to output the largest number. So we need to check if the code has any output statement with outputting the largest number. Then the fourth thing you need to do is to find an average. So we need to do it. It has the total, it has the count, and is it dividing the total and count? And the last thing we need to find is the output, the average. We need to find one statement that is using the output and also outputting the average. Okay. So now let's use this method to find the errors. Okay. So first of all, we need to take 3 numbers. Let's see if the code is taking 3 numbers. So as we can see here, it's using the for loop and it's running from 0 to 2 and it's inputting asking the user to input 3 numbers. So this is correct. This requirement is fulfilled. So there's no problem in this one. Next one, find the largest number. So find the largest number. So what is the problem? How we find the largest number? First of all, we need to have a variable with the smallest value. Okay. So initialize the largest variable with the low number. Okay. The second condition is what? So this is not with the smallest value. It is positive 999. It should be minus 999. Okay. Second one is what? It should check if the data input is larger than the data in the largest. So it is checking or not. So here it's not checking here. It's also, these are the 2 mistakes here so far. Third one is updating the largest variable with the new value. Is it updating? Yes, it's updating this one, but here we have 2 mistakes. Okay. Next task is output the largest number. Is it outputting the largest number? Yes, it is outputting the largest number here. No problem with this one. Then we check find the average value. So it is finding the average value. So here we have a line. Is it finding the average value? Need to have a total. Yes. Do we have a total? So we have a total here. Okay, this requirement is complete. And then divide total by the count. So what is the count? Count is 3. So is it working? So yes, correct. Next, let's see what is the last requirement. Last requirement is to output the average. So is it outputting the average? Yes, here we have output statement that is outputting the average. So this is also correct. So now we know in this code we have 2 mistakes. Number 1 here, largest variable should be initialized with a minus value, right? Minus 999. And here this problem with this line of code. Okay. Okay, so yeah, that's how you find. So next question number 64, identify and describe 3 basic data types. So first one is integer, positive or negative whole number that can be used with mathematical operators. Next one is a real, a positive or negative numbers with fractional parts that can be used with mathematical operators. Then you have the Boolean, a variable or a constant that can have only 2 values, true or false. Next one is char, a single alphanumeric character. And the last one is string, multiple alphanumeric characters. Okay. Question number 65. Write pseudocode statement to perform the following string handling operation on the variables myString. Find the length, convert the uppercase, convert to lowercase, find the first character. Okay, so we know this one. For the length, we use the length function. To find the length, we use the length and myString. Then for convert to uppercase, we use the uCase function. Okay, uCase and myString. Then you have to convert to lowercase. You use the lcase function, lcase and myString. Then you have to find, if you want to find the first character, you use the substring and you give the range from 1 to 1. Okay, so we give you the first character of the myString variable. Question 66, explain the difference between the programming concept of sequence and selection. In your explanation, provide an example of programming statement for each concept. So what is the mean by the sequence and selection? So sequence is the concept of one statement being executed after another. Okay, so it's the order in which the statements are executed. For example, first the first statement print X will be executed, and then after that the print Y will be executed. This is the example of the sequence. Next one is selection. Selection decides which statements are to be executed depending upon the result of an equation. For example, you see if X is greater than Y, then you print X, else print Y. This is the example of selection. Question number 67, give the pseudocode for the following types of statements: an assignment statement, a selection statement, and iteration statement. So what is the pseudocode for the assignment? So we use the X or variable, and then you have the arrow and the value is on the right side. The next one is selection. Selection is what if or a case statement. So if X is greater than Y, then print X, else print Y, and then end if. Last one is what is iteration. So we used what for loop. So for X equal to 0 to any number, and then you have the statement, and then you end with the and for. So next the total shama, and then next is equal to X. Okay, so that's how you can write the iteration, selection, and the assignment. Question 68, for each of the 4 group of statements in the table, place a tick in the correct column to show whether is the example of selection or repetition. Okay, so first one is what? For is what? Is the selection. Okay, good. So yeah, for loop, sorry, not a for loop is a loop, so it's a repetition. Next one is a case. Case is a selection. If is also a selection, and repeat until is a post-conditional loop, so it's also a repetition. Question number 69, take one box in each row to identify if the statement about the subroutine is true or false. A subroutine is called from within a program, so that is true. A subroutine is not complete program, that is it's not a complete program, it's a part of program. Okay, a subroutine is a self-contained piece of code, that is true. A subroutine must return a value to code from which it is called, so that could be false because we have 2 types of subroutines. First one is called the procedure, and second one is called the function. So function return the value while the procedure does not return any value. Okay. Question 70. Okay, so now let's see some database questions. So yeah, let's have a break, 2 minutes, and then we'll start the question about the database. There's one question from this whole chapter, and I will make sure that you will get this question correct. Okay, let's back to the work. And question number 70. A shop that sells books has set up a new database table called book list to store the book details. Part of this table is given. So this table is given. The table name is what? Book list. What is the primary key field and how many fields and records are in the book list table? So first of all, you need to answer this question. Then we go to the next question. So can you tell me the answer for this question? How many number of records in the table and number of fields in the table, and what is the primary key field? I'll give you 5 seconds. You can quickly comment, and then I will show you the answer. So 1, 2, 3, 4, 5 seconds. Okay, so number of records are how many number of records? 5. How 5? 1, 2, 3, 4, 5. Rows mean a record. So there are 5 records in this table. Okay. Number of fields. Field is this one. 1 field, 2, 3, 4, 5, 6, 7. So number of fields, what? 7. And what is the primary key? So primary key is a field in which data is only the unique data is stored. So the most appropriate one for this table is this field, cat number. Okay, is our what? Primary key. Okay. Next question is, what data types would you assign to each of the field in the book list table? Choose the most appropriate data type. The first one is cat number. So cat number, you can see it has a alphabet, okay, ABCD, and also has a number. Okay, so it means we can choose the text or alphanumeric on this one. Next one, the title. Title is ABCD. We can say it's a text. Okay. Fiction, yes, yes, no, yes, no. So it's a Boolean. Okay. Price is what? Price is what is a real value. So we can say it's real. Okay. Question number 71. Write the SQL query to find the book by B pen in the book list table. Okay, so you need to find the books written by this author, B pen. It has two books, right? How do we find? So we need to find the book. So we can say select title, okay, from the table. What is the table name? The table name is book list. Where what? Where author equals to B pen. So where author equals to B pen. It's a very simple way to write the query. Okay. Next one. Question 72. Write SQL query to show the category and title of books that are only in the fiction genre from book list table. Okay. So show what? Show category and title. So we need to show 2 things. So select what? Select the cat number and title from the table. What is the table name? Table name is book list, right? Where what? Where genre is equal to what? Genre is equal to fiction. So genre of fiction. Fiction equal to yes. So fiction equals to yes. Okay. Question number 73. A database table called TV range shows the main feature and prices of a range of televisions. What is the primary key field? How many fields are in the TV range table? So number of fields. How many number of fields we have? Let's see. 1, 2, 3, 4, and 5. Okay, so 5 number of fields. What should be the primary key? It should be something with ID. So storage ID could be our primary key for this one. Okay. Next one, you need to find what is the data type for each field. So find the data type. So let's read the information. So size meters will store the size in the meters. Okay, so what should be the size in meters? It should be the most suitable is real because the size is maybe 1.7, 5 or something. So it's the real value. Position, first, second, or third. So it will store something first, second, third. So it could be text. Okay, alphanumeric because we're storing the letter first, letter second, the word first, word second, and third. Then hoist is what whether there is a hoist available for the transfer of items. So it's yes or no, right? So we can use the Boolean for this one. Then price month. So remember, always price for the price, we always use the real. Okay, price and the scores we always use the data type is real. Okay. Now let's go to the question about writing the query. So a storage unit rental company wants to set up a new database table for the storage unit that can be rented. The table is called storage unit and need to store these details. So these are the details, for example, size meters, position, hoist, price, month, and storage ID. Complete the structure query language SQL statement to display only the storage code, price, and size. So what we know that in the select, we need to specify those columns. So what storage code, price, and size in square meters of all the storage unit where there is a host available. So select what? We need to select what? Display only the storage code. So what is the storage code? So storage ID, right? Storage ID, comma, what? Price and size. And size we have size in meters. So we have to show storage ID, price, month, and size meter from the table. What is the table name? Table name is given here. Its name is storage units. And what is the clause? We need to write here the condition where what? Where hoist equal to what? Yes. Okay. Or you can also write 0 or 1. And because we don't have the table, so we can think that 0 means yes, 0 means no, and 1 means yes, or you can write true or false. Okay. Okay, question 75. A database table called TV range shows the main feature and the price of a range of televisions. So what is the primary key field? How many fields and records are in the TV range table? So number of records, 1, 2, 3, 4, 5. The number of records are 5. Then the number of fields, 1, 2, 3, 4, 5, 6. So 6. And the primary key should be what? It should be maybe TV code, I guess. Yeah, it looks like a very, it's unique. Yeah. TV code should be our what? It should be our primary key in this table. Next is what type of data would you assign to each of the field in the TV range table? Choose the most appropriate data type. So TV code is what? Text, you know this one. Screen size is a whole number. We can use integer for this one. Then smart TV is what? Smart TV is yes, no, so it's Boolean. Price is in fraction, so we can use the real. Okay, for this one. Question number 76. Complete the structured query language query to return the television code, screen size, and price of all smart TVs in the TV range table. So return what? You need to display or return the television code and size and the price. 3 things. So select what? Select the TV code, this one, screen size, and the price. Okay, price is this one. From what is the table name? The table name is already given. Its table name is TV range. Where what? Where the screen size and the price of all smart TVs in the TV range. To return the television code, screen size, and the price of all smart TVs. Okay, smart TVs. So we need to find where are the smart TV? Yes, no. Where smart TV equals to yes. So where should be smart TV equals to yes? Okay. So that's how we write the query for this problem. Let's see question number 77. A company is storing details about their employees' salary in the table called employee salary. The table has the following fields. So for example, employee, write an SQL query to calculate the total salary of all employees in the HR department. So what? So we need to calculate. So we use the function sum, salary, okay? From which table? What is the table name? Table name is employee salary, where what? Where department is equal to HR. Okay. Question number 78. Consider the following sales table that store details about product sales. So this table here, sales, sale ID, product ID, quantity, sale data, and sale amount. Okay. What is the primary key field? How many fields and records are in the sales table? So how many records? 1, 2, 3, 4 records. Okay. How many fields? 1, 2, 3, 4, 5 fields. What is the primary key? I think we can use both sale ID or maybe product ID. They both can be used as the primary key, but the most suitable, let's see. I think for this one is a table name is what? Table name is, let me see the table name. It was sale table, so we can use the sale ID. Okay, so sale ID is the most appropriate for this one. Because maybe this one is a foreign key from another table. Okay, next is what? Is need to find the data type for each field. Okay, so sale ID is what? Is text. Okay. Then the next one is product ID is also a text. Sale date. What is the data type of this one? It is date and time. Okay. Next one is quantity. Quantity is what? Is quantity is a whole number, so we can just write as a date. Question 79. Display the product code and the sale amount of all products that were sold before January 10, 2025. Ordered by the sale amount in the descending order. Okay, so now you have to use the select from where and the order by class. So what we need to display? We need to display the product code and the sale amount. Product code is what? Product ID. So product ID and the sale amount. Sale amount is what? Sale amount. So product ID, comma, sale amount from the table. What is the table name? The table name is sales, right? Where is what? Where the date is what? Date is less than this one. 25, 01, 10. Order by what? Order by the sale amount in descending order. So order by sale amount DESC. Okay, order by sale amount DESC. Sale amount is this column. Okay, so I hope you have got the idea how to use the order by and also the sum. Okay, next question, question 80. A database table museum is used to keep a record of items in the museum. The table has these fields, these item code, description, in-store, century, and the country. Complete the query to display only the description and the country of origin for those items and not in the store. Not in the store. Okay. So let's see. So select what? Select description and the country from the table museum where what? Where in store is equal to 0. Okay. Yes. Let's go to the next question. Next question says a database table nurse is used to keep a record of disposable items worn by the veterinary nurses. This is the part of the table. So this is the table. Okay. Complete this query to display only the item number and the description of single-use item where the stock level is below the record level. Correct. So we need to display what? We need to display the item number and description. Item number. Which one is the item number? So it's item ID, it's item number. And what else we need to display? Description. Description is what? Description, these two. So select what? Item numbers, comma, description from the table. Table name is what? Nurse. Okay, and then where is what? What is the where clause? Only the item number and the single item where the stock level is below the record. So we need the stock level. What is the stock level? Stock level, single use is equal to 1. Single use is equal to 1, and what? Stock level is less than record level. Okay, so single use and stock level is less than 1, less than a record level. Question number 82. A database table. Choco bar is used to keep a record of chocolate bars sold. Chocolate bars are categorized by this one: size, fillings, price, and number sold. Complete the query to display only the price, filling, and the number of sold of small chocolate bars that have sold fewer than 10 bars. So select what? Select the price, filling, and number of sold from the table Choco bar, where what? Where size is equal to small and the number sold is less than 10. Okay. Question number 83. Data about plants in the solar system is stored in a database table called the planets. The fields used in the table are shown. This one: planet name, planet mass, larger, max distance, minimum distance, year length. Complete the query to output the planet within a longer year length and a greater mass than Earth. Assume the Earth year length is 365 days and display only the names of the planet stored in the alphabetical order. Okay. So now you have to read this question. This question is a little bit complicated. So find what we need to display first. So we need to display the planet name from the table. What is the table name? Table name is planet. Okay. Where what is the first clause where the year length is greater than 365? Is 365 is given here. And what is the second condition? Larger is equal to yes. So larger is this column, and is larger. So what's larger table is storing? Is storing whether or not the planet has a greater mass than Earth. So if it's larger than Earth, it's yes. Then we need to do what? Order by what? Order by the planet, sorted alphabetical order. Display only the name of the planet sorted in the alphabetical order. So here is planet name and ascending order, ascending and descending two orders, right? So we use ASC for ascending order. So whenever you're attempting this type of question, make sure to read the details of those fields. Okay, if you don't read, then you won't be able to write the query. If they have given you the table with the data, then it's easy. But if they have given you table with the field name and the details, okay, then you have to read those very carefully when you are attempting to write the query. Question number 84, a computer game shop record its stock level in a database table called the games. The field used in the stock table are shown. So these are the field: game ID, game name, age restriction, game price, number, stock, on order, date, last order, and game description. Complete the query to output all the game that have no stock and that are on the that are on order with supplier. Display only the game ID, game name, and game price field in the alphabetical order of the name of the game. So select what? Select game ID, game name, and game price. From the table name is what? Games. Where what stock level is 0 and on order is equal to 1. And order by what? Order by the game name and order at ASC mean ascending order. Let's see the last question. Identify 4 basic data types used in databases and provide an example for each one. So what are the basic data types used in the databases? So first one is text or alphanumeric. Example is description of a part. For example, anything that you write it in double quotations is text. Okay. Character, for example, single S, M, or L for the size of a part. Okay, or single letter. Then you have a Boolean, it's a true or false value. Then you have an integer, it's a whole number. Then you have a real, it's a number with a fraction point, let's say 12.99. Then you have a date and time, and this store date such as like this one, 18/12/2022, and also store the time. Okay, so that's it for now. And if you have some question, you can write the comments. And if you want me to cover some of the topic, I can cover those topics. You can just write the comments. And see you in the next class. Maybe tomorrow I will come live again and to discuss these questions and some of the new questions. Okay, so until that, see you. Bye bye.